Hi, welcome to part 7 of the section about parabolas. Probably another 1 or 2 parts after this, but we're nearly done. Good job sticking through this far. Okay, so far we have learned that parabolas are graphs of functions of the form y of x equals ax squared plus b x plus c, and also that they can be represented in the form y of x equals k times x plus d squared plus e. And, well, it turns out that they're the same parabola in the case that k is equal to a, d is equal to b divided by 2a. I think I can hear an alarm going off somewhere in the distance. It's off now. D equals b divided by 2a, and e is equal to c minus b squared divided by 4a. So we showed that in this case, in fact, 1 and 2 are exactly the same parabola. This section, however, we're going to learn a third form. Now, not every parabola can be represented in this form, but some can, and we're going to learn when they can and when they can't. So the third form of parabola, which is the one we're going to be focusing on this section, y of x is equal to k, and I've used k because it is going to be the same k as in this case when it can be represented in this form. So y of x equals k times x plus, what letter should I use? I guess we're up to e, so x plus, what comes after e? A, B, C, D, E, F. X plus f times x plus g, where f and g are fixed numbers, and they can be positive or negative or even 0. That's fine. So this is the form we're focusing on for this section, and we're going to learn exactly what do the f and g do, how do they affect the graph. We already know how k affects the graph. If you've forgotten, k determines how fat or thin the graph is, because this is going to turn out to be exactly the same k as this guy here, which is also equal to a, when these things are all the same parabola. Okay, so without further ado, let's crack into an example to really try and understand what's going on. Now, the example is going to be of the following form. The example is going to be the graph of y of x is equal to, x plus 2 times x minus 3. Now we can quickly expand this thing out using year 10 algebra. If we expand it out, we get y of x equals x squared plus 2 minus 3, so minus 1x plus 2 times negative 3, so minus 6. To say that again, y of x equals x squared minus x minus 6. That's how it would look if we wrote it out in full. So we know this thing is a parabola because it fits our original definition with a is equal to 1, b is equal to negative 1, and c is equal to negative 6. So we know it's going to look, since k is equal to, or k is equal to a is equal to 1, we know it's going to be like it's going to have a regular skinniness, if that makes sense. Oops, no, I don't want to clear, so I want to go back. Well, what else do we know? We know that, in fact, this thing is going to, well, since k is positive, k equals 1, we know it's going to be the right way up. So that's another thing to keep in mind. We also know that this thing is going to be equal to 0. We know that this thing is going to be equal to 0 when x equals negative 2. Because if x is equal to negative 2, here's negative 2 over here. If x is equal to negative 2, then we've got y of negative 2 is equal to, I better write this down. Y of negative 2 is equal to negative 2 plus 2 times negative 2 minus 3. And negative 2 plus 2 is equal to 0, and we're timesing that by negative 2 minus 3, so 0 times negative 5, well, 0 times anything is still 0. So put in x equals negative 2, you get 0. Clear some space. Similarly, if we take y of 3, we're going to have 3 plus 2 times 3 minus 3. And that is, of course, 5 times 0, which is again 0 for exactly the same reason. So we can look at these two brackets and determine that x equals -2 and x equals 3. So here's -1, here's 1, here's 2, here's 3. These are the parts of our parabola where our parabola is equal to 0. So we know that our parabola goes through this point and it goes through this point. When I say our parabola is equal to 0, I mean the y value that comes out of the function that our parabola represents is equal to 0. Okay, so what's it going to look like? Well, we know that parabolas are kind of symmetric about some vertical line. So we know that if I draw a vertical line in the middle of this thing, there should be some kind of symmetry on either side. Well, -2, -1, 0, 1, 2, 3. 3 plus -2 is, well, what is 3 plus -2? 3 plus -2 is 1. Oh, I screwed that up, didn't I? The middle is not along that line there. It just looks like it is. Actually, 3 plus -2 is 1, and 1 divided by 2 is 0.5. So our symmetry line should be halfway between those numbers, and halfway between, to find halfway between, we take the average, so it's actually 0.5. So we know that our parabola is going to be symmetrical about that line because it's halfway in between those 2 points. And we can also find out the value that our parabola will take when x is equal to 0.5. And we do that by putting 0.5 into the function. So y of 0.5 is equal to 0.5 plus 2, so 2.5 times times 2.5 minus 3, so times -0.5. I really should have chosen an easier example. So 2.5 times -0.5, well, half of 2.5 is 1.25, so negative half of 1.25 must be -1.25. Yeah. So we know that our parabola is -1, here's -2, so -1.25 is about there. So we know our parabola is going to go through that point. And so that alone is enough to give us an idea of what our parabola looks like. We can see that it's going to basically take this type of form because we know that all parabolas have that kind of curved shape to them, and we can see that it's gone through these points here. That enough is alone to get a pretty good idea of what the thing is going to look like. If we wanted to, we could plot more points, but I mean, I don't think it's necessary here. Okay, so that's how these things work. That's how, let me use a different color here. That's what this +2 and -3 actually do. That's what these two things actually do. They tell us where our parabola is going to cut, the x-axis. If x minus 3 is one of the factors, we know that our parabola is going to cut the x-axis at 3, because when we put x equals 3 into that function, we're going to be multiplying by 3 minus 3, which is 0. So of course the thing that's going to come out is 0. So therefore we must have the point 3, 0 on our curve. Similarly, when we've got +2 as one of the factors, we know that if we put x equals -2 into our function, we're going to have 0, because then we'll have -2 plus 2, which is 0 times -2 minus 3, so 0 times -5. All right, so that's what these factors here do, and that's how we use them. That's how we can get an idea of what the graph looks like. Okay, so that's all well and good. What's next? Well, remember before I told you that not every graph can be represented in this form. Not every parabola has that representation. Y of x equals k times x plus f times x plus g. Not every parabola has that form. Well, let's take a look at one that won't have that form. This is the x-axis. Well, I'm actually not going to draw it yet. Let's take a look at the parabola y of x equals x plus 2 squared plus 3. Well, I can tell you right now, we are never going to be able to get it in the form y of x equals, well, k is 1 here, so x plus f, x plus g. And I can tell you that it's never going to be, we can never write it in that form for the following reason. Let's go ahead and actually draw the thing. Oops. Let's go ahead and draw the thing. So here's our x-axis, here's our y-axis. Well, x plus 2 squared, that tells me that we're going to actually shift to the left by 2. So that's going to be where our turning point is, where x equals -2, somewhere along this dotted line. And also the plus 3, so the plus 2 tells me it goes to the left by 2. The plus 3 tells me it goes up by 2, by 3 rather. So here's 3. So our turning point is going to be here, and our parabola is going to look something like this. Well, if we could represent our parabola in the form x plus f times x plus g, then when x equals -f, wherever that is, I don't know, maybe -f is over here. When x is equal to -f, we know that our parabola should equal 0. But that never happens. Our parabola just keeps going up in that direction, keeps going up in that direction forever. It never cuts the x-axis. And when the parabola cuts the x-axis, like this, here's -g. When our parabola cuts the x-axis like this, that means that the y value that comes out is 0, because this is the point, this is the line y equals 0. So if I put -g into y1 of x equals x plus f times x plus g, I'm going to get 0. And if I put -f into y1 of x equals x plus f times x plus g, I'm also going to get 0. So if this parabola could be written in some kind of form like this, then its graph would cut the x-axis. Since it doesn't cut the x-axis, we know for sure it can't be written in that form. Okay, that's all for now. Thanks very much for watching. Don't forget to check out the notes and make sure you have a go at those exercises. I think we'll probably do one more part to this section on parabolas. For now, take care. Bye.